What goes first?
I'm going to start with the 50.
50.
Particularly friendly to the faint-hearted. Kind of made sure that there weren't going to be a bunch of people using them.
Right.
And
so you're like, sign me up.
Yeah.
That looks really cool in there.
Yeah. Okay. So that's what draws people to it. They see this and equate that with the sound.
I don't know about that.
That's what people do.
Huh.
I mean, that's what people...
I've just never seen one of these before.
That's what people that think of themselves as Hiwatt aficionados, that's what they all glom onto.
That's hot shit. 1974?
Yeah.
Wow.
Let's see. Yeah. You can see the date code on the capacitors. Although I don't want to move that and break the wire, but this one has the date code right there, 7428. It's the 28th week of 1974 on that capacitor.
Wow.
And on the pots, the same thing. You see, right here, you see that? It's 7437, so that's 74 and the 37th week. Right?
Wow.
So these different pots are from, there's a couple of different batches here, so some of them are in 74. This is 36. I thought I saw one that was 31 or something like that, but
that's the youngest pot.
Yeah,
possibly.
Right. So this is the AC input is set to 115 volts.
Okay.
And my voltage monitor is plugged into my step-up transformer, so it's saying 230,
okay,
which is double 115. I set it to 115, but because I'm using the step-up transformer output for my voltage meter, it says 230, which is 115 US. So even though it says 230 here, 115 is getting to here. How I know is I just take that number and divide it by 2.
Okay.
And for my sine wave, I need to get it into the phase inverter.
So you changed it to 8 ohms. What was it before?
16.
16, right?
Yeah, but my test load is 8.
I see. But you're going to do that to the 100 watt as well.
That's right. I want to get past all of the preamp stuff so that I'm just running signal directly into the power amp to get the power output reading. So, this is ground. Feeding the signal in at the master volume so I can adjust the output. So the presence and the master volume are the only things that are going to be working right now.
Interesting.
And we're going to take a reading off of the main power supply, see how it behaves at 0 output and full output. So, that is 522 with no load. And I have a 1 kilohertz signal coming in. Right. Sine wave. So, now, go. There's clipping right there. And that's clipping right at 20.5 volts.
Okay.
20 volts is 50 watts right on the nose. Now, when I go farther into clipping, the output doesn't go up very much. 23 volts is about 60 watts, so that's into some serious clipping there. So it doesn't really go way out like the 100 would. And then looking at it as a square wave, here's what the presence does. The presence control operates on two parts of the circuit. One part is adjusting the frequency of the high frequency, the feedback network. And as you turn it higher, it's rolling off high frequency response of the phase inverter stage, and that's this more broad activity here in the last
You're not even sweeping it much.
no,
to get
that's
that.
that's the last couple of notches of the presence
Interesting.
control.
Yeah.
So it's kind of a unique two-stage presence circuit. That
So wait, what happens when it's all the way? Okay, so now we're basically the presence is out of the circuit or off, or
it's
lowest?
yeah, it's essentially off, but there still is a little bit of high frequency rise right here, which is kind of inherent in the design.
Okay.
That's part of what always keeps it articulate sounding.
All right.
All right, so
By design or happy
Yeah.
accident?
no, by design, I'm sure.
Okay.
Okay, so now when we're looking at the idle plate voltage, this is in standby mode, we're at 523. Under load but not produce any signal, we're at 477. In fact, I'm going to write this down.
I was gonna say we need to keep track of this because I'm not gonna remember.
I won't either.
That's good to know.
All right. Standby 50, 100. 523. On idle, which means standby in operation mode but not doing any amplifying.
Nothing's being played into the
Right,
amplifier.
we're at 478. And then we go up to right at the onset of clipping. And
Which is where, if we're thinking about
that's
clock face on the master.
well, it's kind of irrelevant because it's dependent on how much
oh
signal
yeah,
level
yeah,
is
yeah.
coming in
Right,
from.
right. Okay.
See, I mean, if I turn the signal level
This
down,
isn't a guitar.
turn the signal level down here, I have to turn master up more to bring it up to full clip.
I see.
So it really depends on where you set the gains. This is my normal setting that I use for test purposes, so that I have enough voltage to drive the power into full output. And there we are that's at full 50 watts RMS, just at the onset of clipping, and we've dropped down to 415 volts. At clip, and then when we go into full saturation, which is like practically a square wave,
I was gonna say that it's a square wave. Yeah.
full saturation drops down to 387. 387. Okay. And we're at 27 volts at full saturation. 27 volts at 8 ohms is about 98 watts. I should write that down too. Okay, so we're at clipping, we're at 20. At clipping, we're at 415 volts, 50 watts. And at full saturation, we're at 387 volts, 20, that 27 is actually 27 squared divided by 8, 91. 90 watts. Okay.
100 watts.
This one is a repair. It has Veetlana EL34 is in it.
What did you think was in there? JJ's?
I didn't remember. I thought that they were. I thought that I put Mullards in there when I did the repair, and maybe the customer changed them later. I don't know about that, but they're Svetlana's. But they're current production Veetlana, so that means that they're the Svetlanas that are made in the reflector factory, not the Veetlana factory. Still a good tubes.
I was going to say, big difference in performance?
They tend to be a little sparklier, but not a whole lot.
The reflector factory is sparklier. Is that what you're saying? Or the original?
The original Veetlana tubes are a little. They're actually a little bit bright and bottom heavy to me.
Okay.
People like them because they can handle a lot of power and they sort of thump. But in a Hiwatt, they're a little bit.
Well, I was going to say that sounds like something that would be desirable, but not necessarily in this circuit.
Now, this being a repair, it has a Habor power transformer, which is a Hiwatt reproduction transformer, a partridge reproduction.
And when you repaired it, did it have the broken partridge in there?
Actually, it had been taken out.
Okay.
And sort of horribly extricated by somebody without a lot of finesse. So I spent a lot of time going back in and grafting the new wiring into the original.
Oh, you had to do all that to make it look.
Well, I wanted it to look original, so yeah, I had to do a little bit of grafting work to use the original loom. And I wanted it to look like it still had the original loom.
Sure.
This is all the original loom. All the way around here to here, all the way over here. Of course, this is the original transformer, so all the original wiring except where the new power transformer splices in here.
Okay.
And where it connects to the filaments and the high voltage supply here. It's obviously new and doesn't have the threaded looping, the
Here. That
right.
is what we're looking at.
Versus the old school. Right.
Okay.
So I just did my best to try to get it to lay down like the original.
And what material were they using in there? What is that?
It's a wax impregnated cloth.
Yeah, it looks like thick dental floss.
And what you do when you make a loom like this is there's a big board that's got a bunch of nails on it or screws or whatever.
Okay.
And you cut all the wires to length and lay them out on this board. And then you wrap the loom with these wires all up on this board.
Okay.
You don't do it inside the amp. You do it separately.
Because that's just brutality.
Right. You create the loom outside of the amp, and then you put it in, and of course you have to.
That reminds me of the wiring of the ES guitars with Gibson. You make the harness outside of the guitar, right?
Yeah, but there is a little bit of a trick, because you have to incorporate the transformer winding into that loom and the transformer winding into that loom. This part is easy because you just loom the transformer wires before you install the transformer, because the whole loom assembly will go through the hole. In the case of the power transformer, the leads, part of loom actually has to be, I honestly don't know how they get that in there. I don't think, normally making a loom, you do it externally with a jig. But there's no way that you got the transformer wires
Right.
incorporated into an externally
Well, you can't.
jigged loom.
It's physically impossible. It's
So-
just the chassis and
So it would have to be,
chassis.
all of the heat shrink part, all of that would have to be assembled up to a certain point, and then you put it, with the heat shrink and all of that, and then you install it, incorporate the transformer winding in underneath it, and then wrap it, which you would probably have to do without the fuse holders installed or something, because you need to be able to get it. It's kind of has a little bend here, so maybe you bend it upwards to complete the loom, and it's like you loom it out this way, and then you bend it here and install it, and you've got your leads hanging out.
It's funny to think that there were people who were good at this and fast and efficient at this.
Yeah,
That was their gig.
That was the whole.
Wow.
That was the whole Harry Joyce thing, which is he was set up to produce things like that, and had people trained to make those things. So it was a skill set.
Yeah.
But of course, you had to do it quickly, and there's no amount of quickly that compensates for the cost and the labor time to do that, which is why you didn't see it in Sound City amps, because there wasn't any way that Ivor Arbiter was going to pay people to do that meticulous kind of workmanship.
Sure,
It was like
sure.
not at the price that he was trying to sell Sound Cities for. So a big part of the labor in this Sound Cities was just eliminating time cost, just eliminating just pure labor time, and the only way to do that was just put the wires in, solder them, on to the next. Don't waste my time with pretty. And I'm sure that would have been a big part.
So, anything else here inside the 100 visually strike you?
We're kind of going to have a look at that. Okay. So here we have. I'm just connecting the signal in for now the same way, but if we compare both of them, we see that we can just go down the turret board and compare component values.
Okay.
So this is the same. You got the 560 ohm resistor, which is a key component. This is really a critical component value in this design. And then you got a 1 meg resistor with the 22 nano capacitor, which is there, and then two 100Ks that tie into the presence control circuit. This one has got a 100 ohm resistor coming from the wiper of the presence control to that 2.2K resistor there, and this one also has the 100 ohm resistor. So that's the same. It looks like it might have been replaced, and if I recall correctly, this has got Harry Joyce's initials on it, by the way.
Oh. Yeah, right there.
Which is part of why, once I saw that, I thought, okay, I'm gonna have to just do the most pristine job possible in a thing like this, because just out of pure deference to Harry Joyce. So that's just, some of that little anal stuff that you do because you feel you need to.
Well, it's fun too.
22K there, and then capacitor values are the same there, and then here's the one of the phase inverter plate resistors. It's 82K, and over here we have 82K, and then 47K there, 47K there. It doesn't really look like a 47K, but it probably is. I'm going to double check that just to be sure. Then we got a 22K, which is a power supply decoupling resistor, 220K. That's in the tone control circuit. These are all pretty much the same. Pair of 100Ks there. Tone control coupling caps there. 1K cathode resistor there. 10K power supply decoupling resistor there. And then the 220K plate resistor on the input stage. 1 or 2. Another one there. 2.2K cathode resistors there, and their associated similar cathode capacitors there, which are all the same. So the whole turret board assembly on both of these is identical.
Okay, 1500 watts, same stuff.
Right. Now if we go back on the power supply board, we've got a full wave rectifier bridge here where we have a it's not a full wave bridge, it's a full wave center tap supply over here, which is typical. You don't do a full wave center tap on a 100 watt amp normally because you have a really high turns ratio on the secondary of the power transformer to accomplish that, which tends to make it more susceptible to failure down the road. So when you get up into higher power ratings like that, you want to keep the secondary voltages, more under control, and you do that by using a full wave bridge. So then the stopper resistors on the power tubes are all 22K on both, and the screen grid resistors on both.
Ooh, nice save.
Yeah, I'm sort of trained to do that.
Knock it over and make sure it doesn't fall on the floor.
The screen grid resistors on the 50 are 3 watt. Looks like they're between 3 and 5 watt resistors over there. They're half watt resistors here, and that's pretty common. It's a very low wattage value for a screen grid resistor, but that's what they used. I guess the rationale there was that if you short a screen to a plate when you're putting out full power, you're going to smoke a half watt, you're going to smoke a 5 watt. Either way, you're going to smoke the resistor and have to replace it. So what difference does it make if it's a half or a 5 watt? But at some point, they just decided, well, you know what? A 5 watt under an intermittent short condition may survive a short like that for a short interval of time. So screw it. Let's just play it a little safer. And also on the 50 watt amp, you're more likely to push it all the way into clipping than the 100.
Sure.
And once you go into screen grid clipping, control grid clipping, once you clip the control grids of the power tube, the screens just draw all kinds of current. So the likelihood that you're going to be drawing screen current on the 50 is way higher than on the 100. So that could be a rationale for going with.
Now, is that just because of the usage, the way people are using them? Is that what you're saying?
I would say. I would say it's just going to be more likely that you're going to be taking a 50 and cranking it all the way up because the band's going to be loud and you're going to be trying to keep up.
Yeah, and this is going to hurt people.
This is going to hurt people, so it's the likelihood that you're going to push it well into the saturation point where the screen grids start pulling current is probably a little less likely just because of how lethal it's going to be at that volume.
Right.
And whereas on the 50, you'll be able to do it all the time with impunity, so you need a little bit extra level of safety consideration there, or overload consideration there, just in the name of reliability. But all of what we're seeing basically is all of that is okay. There isn't anything different except possibly this one resistor here that's supposed to be a 470K and the other one, and it's discolored here, but it looks like a 470K. Yeah, I mean, if it's got a red body instead of a beige body, so the when you look at it, you know, optically, the relationship between the body color and the color code color will always throw you a little bit until you get accustomed to the body color, and then you go, oh yeah, it's right. But we'll look here, and we'll see that that's probably 470K, and it's showing 82K, which it's not. So that's going to be reading in circuit. That it's connected, the way it's connected in the circuit, there's voltage, I mean not voltage, but there's interaction between a related component in there. So
yeah.
Measuring it in circuit isn't going to help us. That was 82K, so this is an actual 82K resistor here. This is a plate load resistor, and it's showing 60K, and that's because there's a little residual voltage in the filter cap that's skewing my result there. This one is going to be related to...
Did you just discharge anything when you...
No.
jumped? Yeah.
But this is clearly... Oh, wait a minute. Okay, so here's the 82K here, and it's also reading... Oh, that's reading 87. And then here is the 91K, which is the other plate resistor, and it's reading 92. Okay. So now let's go back over here. And here's the 82K. It's reading 50, but it's an 82K. If I disconnect one end, or maybe take the tube out. Oh, see, I have the power on. That one I don't have the power on. So we're getting a skewed result because there's current. There's not current on the preamp tube yet, but there is heater voltage, so it is doing something. So when we pull the tube out, so that even though there's no voltage on the plate, there's filament current. So there's electrons flowing in the tube, and that was skewing my result. So here's the 82K plate resistor here, and so this one now should read 91. And there we are. Okay. So even though the white band on this brown body resistor looked like a yellow band, which would be a 4. So that's why I got that was a 47K resistor. And so we'll put the tube back in. And this, by the way, this looks like an RCA. And it's got some, Zenith, which is probably RCA. Various companies. Zenith is not a tube manufacturing company, but a television manufacturing company. So they would have probably bought the tubes from RCA and had them branded Zenith, just like we brand some tubes for Hiwatt these days. It's a branding exercise, not a manufacturing exercise. Okay. So everything is identical in the preamp and the power amp stage, except for the power supply configuration, which we knew.
Very interesting.
So now we're all warmed up, and I see what you're saying about did you discharge the caps, because I'm sticking my digits around in there with impunity, but that's just out of years of habit. I know that I'm going to get thrown a little bit, and that's going to be like, well, I could go have another cup of coffee, or I could just touch the power supply and accomplish basically the same thing. All right, so this should be the plate voltage here, and we have to get into voltage mode to read that. And okay, so in the 50, we had 523 volts DC on the supply. In the 100, we have 470 at no load. Now, that would make sense. You have twice as many power tubes that can produce more output power. You don't need the same plate voltage in the 100 as you do in the 50 to get the same voltage swing. You can use less voltage, but you have more current available.
Okay.
So that doesn't mean that the transformer is made wrong or it's the wrong voltage. It's just that the higher powered amps typically had a lower voltage potential on the power supply because it's a full wave bridge. That's part of it, and the tubes can develop more output power based on the design of the output transformer. That's the other part of it. But if you check over here, we're still at the amp. This amp is set to 115 and we're still at 230. We've kind of drifted up to 232, so let's pull it back a little bit, which means that this voltage dropped down from 470 to 466. But I'm just going to leave it at 470 because it's going to drift around.
Okay.
And then we go to, let's see, let's put a load on it and make sure that we're at 8 ohms, which we haven't done yet. All right.
Again, for the viewers, playing these amps through a cab, it's normally set to a 16.
A 412 cab, yeah.
Yeah,
set it to
yeah.
16.
But
for the purpose
for this
of
test, we're setting it to 8 ohms.
You know, being able to do the power conversion, you know, in my head instead of having to use a calculator and all that, it's just easier to do with 8 ohms. So we got that, and then we turn the standby switch on, and our voltage drops down to 450, 447 to be precise. 447, as opposed to the 50, which was 478. So 30 volt difference there, just like roughly a 50 volt difference on the unloaded supply. Again, normal. Now we turn the presence all the way down and we run her up to clipping. Now we are at, remember on the 50 watt head, we were at 20 volts at this same clipping level here. 20 volts RMS, which is 50 volts right on the nose at clipping. We're at 27 volts here, which calculates out to about 91 to 92 volts RMS at the point of clipping. We also lost about 3 volts of supply because I've got a step down transformer that I use for European voltage. I've got a variac here, so there's a little bit of voltage drop across there. So when you start pulling current through it, the voltage drops through all my test equipment. So we compensate for that by just jacking the voltage back up to 230 so that it's 115 for this guy. I'm just going to go to 231, and then we'll hit that clipping, and then we'll be at 28, which is 100 watts right on the nose. That's where we want to be. Now, with that said, if I turn the master volume down to 0, the line voltage will recover 5 volts, and that'll drive up the idle voltage a little higher. So we checked the idle voltage and the no signal voltage with the variac set to 230, which is the equivalent of 115 over here. And then we compensated for the voltage drop through the variac by turning it up when the voltage dropped down, so we would still be at 230, so that we would have an accurate comparison between this unit and this unit. So now we're at clip at 447. Let's see, we were idle at 447. So we're at clip now, 28 volts, 100 watts, and 400 volts DC, which was 415 on the 50. All right. Everything is doing exactly what it's supposed to be doing so far. And if you look at the sine wave, there's very little crossover distortion there, just like in the 50. So this has got original Mullers in it, and this has got Veetlanas, and they're behaving exactly the same, just like you would expect them to. You don't need to put the voltage doubler bias circuit and a pot in there. That's just unnecessary. It's designed to be operated with whatever good quality EL34s you throw in it, and it'll be biased in the proper range, and you don't need to screw around with a voltage doubler bias circuit to make it user adjustable, because you're going to be adjusting it for the right point anyway.
Right.
And one of the things that happens on a voltage doubler circuit, you double the voltage, but you reduce the current. So it'll actually cause a little bit of additional voltage drop through the bias circuit when you do that. So the trade-off, it just plain isn't worth it. It's just a sort of a snob conceit to do that. I've never found it necessary. And this is my 50 watt. I didn't do it on that. This was the customer's repair I did. I didn't do it on that because it doesn't need it.
Now, explain again what happens with the voltage there.
Well,
Because
the
wouldn't that
original
affect how
Hiwatt
it
design
feels?
provided exactly the right amount of idle current using EL34s to be biased properly.
Mm-hmm.
And if you get a pair of really hot EL34s and you're really pounding the amp, like say maybe into an attenuator, you might red plate the tubes a little bit. And what's the fix for that? Don't use overspec power tubes. The alternative is, oh, it's not enough bias current. Well, we need more voltage. Well, how do you get more voltage? You either put a supplementary transformer in there and build out a different bias circuit, or you use a voltage doubler circuit on the existing design, which raises the voltage, and then you put a pot in there to dial it back down to the range that you can't get to with the stock setup.
I see.
Great, except when you double the voltage, you half the current. So you run into more of a voltage drop situation at full output with a voltage doubler bias circuit.
But then the amp's going to feel different.
It'll feel different. It'll play different. You bet. So we don't need that.
Yeah, we don't want that.
Now, one thing to note is that I think we were closer to noon on the master volume on the 50 to achieve clipping, whereas on this one, we're way down there, around 9, 10 o'clock.
Huh.
Okay, so now we're going to go up to full saturation, the square wave.
The square wave.
Which we got to by just turning the master all the way up. And here, we're at 381 volts. The 50 at full saturation was 387. So you see, as the demand on the power supply increases, the difference between the voltage on this one and this one tends to converge, because you're maxing everything out. You're drawing the maximum amount of current out of the power supply that is designed to produce in both cases. So what you see in the difference between the power supply voltages at the onset is that they're compensated for what's going to happen when you max it completely out. You have more regulation and you have more voltage reserve in the 100 over the 50 because you're not using it yet. But when you get to the point where you're really using all of the power that the power supply is capable of delivering to the tubes, then the output voltage, the full load, the full clip plate voltage starts to look very similar on both amps because they're both maxed out, and that's by design. Absolutely. Now if we look at the square wave with the presence all the way down, it looks just like the other one. And as you turn it up, it does the same behavior there.
Okay, and with it all the way down, does it still have that little rise?
Yep. Little rise right there.
Yep.
See? And we get that real spiky. This is a very high frequency. This is like up into 10K. It's 8K.
Again,
this is where the Hiwatt presence.
That's what I was going to say.
That Hiwatt in your face thing really gets its. Now, why would the 100 sound a lot brighter than the 50 set like that? Because it's got more power to produce it. Where this one, you push it up that high, and I don't know if you noticed, but you see how it clips off here when I max out the presence control? That squared off spot right there.
Right.
This is the power amp clipping with the presence control cranked. Now on the 50, that clipping occurred much lower. It started happening around the mid-range of the presence control. So that is a clue to the extra upper mid-range kill power of the 100 over the 50 is the power transformer, the power supply, and the output transformer, the larger size, has the ability to produce more high frequency content before you max it out than the 50. So that's why it would be.
That's what I was hearing.
That's why it would have more scratch and claw
Okay.
at the threshold of intolerable volume, because it can get there where the 50 can't. Right? So that's where it starts to be like really painful to listen to. All right. So power supply differences don't really have an impact on the overall behavior tonally of the amp. Circuitry wise, component for component, they're identical. And the 74 year, I mentioned this 560K resistor here over on the far left, right behind the master volume. On other earlier models and slightly later models of the 50 and 100, they used a 1 meg resistor in there. What that does, a 1 meg resistor would cause less of a voltage drop from that stage going into the phase inverter stage,
Okay.
which would give the amp more gain. This particular series of amps that had the 560K resistor in it tend to be a little cleaner. They seem like they have less gain in the preamp because the gain has been attenuated more using that resistor.
I see.
They have the same amount of gain all the way up to the just before it enters the phase inverter, and then they attenuate it down to keep it from sounding fizzy. And then later on, they opened up that value. Actually, before this and later, they used the 1 meg value of resistor there to push the power amp harder. And I don't know why they did that and then stopped doing that and then did that again. Probably because originally it sounded a little too fizzy and they decided to cool it there to give it a more balanced sound. And then when people wanted more gain, they went back to that configuration to give it more apparent gain.
Yeah.
Make it a little bit more sensitive for strats. But that's way out past the gain stage is what they could do. So that's a variation that you can see from model to model that gives the amp an overall less or more gainy vibe. I particularly like the 74s with that 560K resistor in there because I like.
But you could do the 1 meg and then like it's an easy.
It's an easy thing to do.
Yeah.
But what I look for, what I was always after with the 50 was that output transformer saturation, and what I hoped to get when I switched to the 100 was that same output transformer saturation, but with a little bit more horsepower behind it, which I got, except the little more horsepower turned out to be a lot more horsepower.
Yeah.
I wanted 2 horses, I got 6.
Right.
So that's really the key thing there that establishes the difference. Now, with the Sound City, I looked at the experience that I had transitioning from this to this and went, somewhere in the middle there was the right formula. That's what I did with the Sound City. Was I used an output transformer that didn't have quite the efficiency and linearity on the top end as the original partridges, because it's just too much. And these days people don't really want that. Even people that say they want clean, that's like an extra level of clean that part of why it worked with the original Fane speakers is because the Fane speakers, they were designing them, their design were progressively going towards more power handling and more bulletproofness, right?
Okay.
One of the things that they did to accomplish that was they went to fiberglass voice coil formers, which had more mass. And they also went with speaker cones that had more mass. So when you have more mass like that, it tends to roll off the high frequency. So basically the speakers got darker and the amps were really bright. So the speakers were used
It's a great balance.
to sort of manage the top end quality. So when you put a Hiwatt through a Celestion and you'd say, oh, it's just like it's unbearable. Well, it's unbearable because the Celestians have that upper mid-range bump. So when you put an amp that's this bright in front of a bright speaker, then it's really over the top. Of course, the Celestians they would break into distortion more easily. They were designed to, where the Fanes were designed to stay cleaner longer.
Yeah.
But they were also darker on the top. People sort of describe Fanes as being bright, clean speakers. Well, later on in life, when they started getting up into the higher powers and stuff, they did get a little cleaner and more detailed. And remember that thing that we did with the three cabs, and we had the Sound City cab that had no logo on it.
Yeah, the
and it had
transitional
with the little silver domes on it.
Yep.
That was an attempt to take that high mass, low power speaker and eke a little bit more top end out of it, and you could see by listening to it that that was a little bit much.
Yeah, it's funny because it gave you so much that it almost. I remember that cab having kind of a scoop mid range.
Yeah.
Am I right about that?
Yeah, because the
Was
top
that-
end was emphasized.
Yeah, the top end is kind of like raising that
Right.
end of the spectrum up, so that now we kind of have a V going on
Yeah,
there.
but that wasn't a Hiwatt thing. That was a Sound City thing,
Sound
because
City
Sound
thing,
City
yeah.
development was going away from the partridge transformers, getting more saturation in the top end, taking out some of that super efficiency of the very high frequencies and making it more guitar friendly.
Yeah.
So there was a reason for that speaker to exist with that amp, but with this amp, it just didn't make any sense. So with the development of the new Sound Cities, I wanted a little bit more chime and sparkle to come out of the whole system, and so the new Fane speakers have a little bit more clarity and detail than the original Fanes, but they have that tight bottom end and that smooth mid-range like the original Fanes. So basically, with the Sound City, we take down that top end kill power out of the amp, but emphasize the upper frequencies coming out of the speaker, which results in a more pleasing harmonic blend on the top as opposed to just that scratchy top.
Right, and the cabinet design is slightly different too. Right.
A little bit, yeah.
Because like overall, that presentation, the Sound Cities through the newer Sound City cabs, I always noticed like there's more of like an air. I call it like a three-dimensional quality to
Yeah,
it.
there's more air. Sort of a-
Maybe slightly less like bam, just like punch you in your nose.
yeah, because people aren't going on stages and trying to punch people in the nose anymore.
Exactly,
Well, I mean,
yeah.
some of us are, but we're not getting away with it.
Well, that's why these exist.
Yeah.
All right, back
All right.
to our studio audience.